Hello everyone, welcome back to In Hand Automation. In the previous video, we discussed why AI is becoming important for QA engineers and what we are going to cover throughout this complete series. Today, we are starting phase one of our course, which is AI Foundation. And before we start using AI for testing, there are few basic terms that we really need to understand. What is artificial intelligence? What is machine learning? What is deep learning? And what is generative AI? You have probably heard all four of these terms, but what exactly is the difference? Is machine learning the same as AI? Is deep learning is another name of AI? Where does ChatGPT fit? And as a QA engineer, do I really need to understand all of this? Yes, but you don't need complicated mathematics to understand it. So instead of starting with definition, let's continue the story of our QA engineer, Rahul. So, if you have watched episode 1, you already know Rahul. Rahul is a QA automation engineer working on an e-commerce application. His team has a large automation suite. Every day, hundred of test cases are executed through their CI/CD pipelines. One Monday, Rahul's manager come to him and he says, "Rahul, we have another problem." Rahul asks, "What happened, sir?" His manager says, "Our regression shoot is becoming huge. We now have around 2000 automated test cases. Every time developer make a small change, we run almost everything. It takes too much time. Can we make our testing process smarter?" Rahul starts thinking. Until now, his automation framework was very simple. A test was selected, framework executed it, it passed or failed, that's it. The framework did not really understand anything. It was simply following instructions. So Rahul asked himself, can a computer system actually make an intelligent decision about testing? And this question takes us to our first concept, which is artificial intelligence. So let's forget software testing for a moment. Imagine I create a computer system and I want this system to perform some task that normally require some level of human intelligence. For example, understanding the language, recognizing the pattern, making some decision, or generating some information. So the broad field of creating system with this kind of capabilities is called artificial intelligence. So AI is the biggest concept which we are discussing today. Think of AI as a large umbrella. Okay. So under this umbrella, there are different techniques and technologies. Machine learning is one of them. Deep learning is another area inside the machine learning. And technologies such as generative AI can be built using these advanced learning approaches. We will connect all of them shortly, but first let's bring back Rahul. Rahul goal here is I want my testing system to make a smarter decision. For example, which tests are more important? Which tests have a higher chance of failing? Which applications area is more risky? Which failure looks similar? These are the intelligent tasks. So Rahul is entering the world of artificial intelligence with you guys. So, but there is a problem. Now, again, what is the problem? How will the system know which tests are risky? Rahul cannot write it manually a rule that for every possible situation, which one may be a risky, and that test that particular situation takes us to the new concept which we are going to learn is machine learning. So imagine Rahul has a test execution data from last 2 years. Okay, thousands of test executions has already done. For each execution, he is having information like which module got changed, which test cases were executed, which test cases got passed, which got failed, how many files are changed, which APIs were impacted, how many defects were previously found in that module. Now, imagine Rahul gives all of this historic data to a system. Instead of Rahul manually writing the rules like if a payment module changes, run this test case. The system start looking at the historical data now and it noticed a particular pattern. For example, whenever the checkout module change, these 25 or 30 test case frequently fails. Or when both payment or we can say order modules are changed together, these integration tests have a higher risk. Now, when a new code change come in the system, our system can predict these tests have a higher probability or chance of finding a problem. This idea is machine learning. So, in the simple term, if we conclude the machine learning allows a system to learn patterns from a data and use those patterns to make a prediction or decision. This is very important difference. Traditional programming usually works like we have a rule and we have a data, and based on that we'll be getting the answer. This is what traditional programming is. We write the rules, the computer follow them, and how machine learning is different here. We provide the historical data and we provide the examples. The system learns the pattern from these examples and build a module that can make a prediction on a new data. So let's make this even easier. Imagine Rahul has the historical information for payment module which changed. 20 payment test case got failed. Now another release comes. Again, the payment module is changing. The 15 test cases got failed. Again, another release came. Only profile module changed. Payment test cases are passed. Again, another release came. Checked out and payment changed. Okay. Many checkout and payment test cases fail. Over the time, our machine learning module start identifying the relationship between the code changes and test failure. So tomorrow, when another payment changes happen, the model might say, based on the previous execution, these 25 to 30 test cases should be given higher priority. Notice the wording. It is not saying I know for, for sure that these tests will fail. It is making a prediction there's that based on a pattern which I learned, I am giving you these numbers. That is very important idea in machine learning. We have different types of learnings in the machine learning. Let's go one level deeper. So you might have heard a term like supervised learning, unsupervised learning, and reinforcement learning. Don't worry about the names. Let's understand them using the Rahul. Okay. So suppose Rahul gives a historical data to a system and every example already contains the answer. For example, test execution 1, environment fail. Test execution 2, product defect. Test execution 3, automation failure. Test execution 4, test data issue. So the system has both in the input information and the correct category. It learns from this labeled example and later Rahul gives it a new test failure. The system predict this looks like an environment failure. That is basic idea behind the supervised learning. So supervised learning learns from the example where expected answer or label is already available. So that's what the supervised learning is. Now imagine Rahul has a 10,000 failure logs, okay? But nobody has categorized them. Rahul simply asks, can you find the pattern in these failures? The system analyze the data and start grouping the similar items. Maybe it discover these 500 failures look similar, these 300 another failures look another pattern, share another patterns, and another 200 have something else in common. So Rahul then investigate those groups. This is basically an idea behind unsupervised learning. The system is not given the correct level before the hands. It tried to discover the useful structure or pattern in the data. So, unsupervised learning discovers the pattern without the predefined labels. Now, let's move to the another type of learning, which is reinforcement learning. So what happens in the reinforcement learning is, again, Rahul creates an intelligent system that can make some decisions. The system can choose an action. If the action produce a good result, it receive a positive signal. If the actions produce a bad result, it receives a negative signal. Okay. Over many interactions, it learns which action lead to a better outcome or which action gives us a positive signal. This general idea is called reinforcement learning. You can think of it like learning through the interaction, or maybe we can say in our general term, feedbacks. So, for our QA journey, you don't need to go deeply into the mathematics. Just remember the higher level, the difference between all these three learning is supervised learning, learn from the labeled example. Unsupervised learning learns from the unlabeled or without predefined label examples. Reinforcement learning learn through the actions or feedback. Now, now everything was going well now. Then again, Rahul's manager comes with another request. Okay, so what is the next request now? And whenever the manager is coming, Rahul is getting another problem. So manager says, Rahul, predictions are useful, but we have another problem. Our application has hundred of pages. Sometimes the UI looks wrong, even though the functional automation test cases are passing. Can we make a system which can understand the screenshots or UI? Now the things become more complicated. Earlier it was about the data. We will having we were having around different types of data, and based on that our system were predicting very well. But what about the screenshots now? Rahul has a screenshots of button, images, text, layout, different screen size, visual pattern. Normal machine learning techniques can solve many problems related to data, but for the very complex data such as image, audio, or large amount of text, we often need more powerful learning or more powerful architecture. And that's take us to our next learning, which is deep learning. So, deep learning is a specialized area of machine learning. It uses the structures called artificial neural network, especially networks with many layers, to learn complex pattern from large amount of data. So you don't need to understand all the mathematics behind the neural network right now. Think about think about in a way, suppose to understand that screenshot, we may need to manually define many features like where is the button, what shape it is, what text it is, what does the image contain. Deep learning system can learn useful representation and complex pattern from the large amount of example. This is why deep learning become extremely important for areas such as image recognition, speech recognition, natural programming process, computer vision, and many modern AI systems. In our day-to-day life, if you are giving a command to Siri, it is speech recognition using deep learning. If you are sending some image to a Gemini and asking for what image it is image recognition using deep learning. Okay. So let's connect this back to the Rahul. Suppose Rahul has two screenshots. One is expected, another one is actual screenshot. A basic pixel comparison might say a thousand of pixels are different. But maybe the only difference is that the time step change. That difference may not matter. On the other hand, maybe the checkout button disappeared. That is extremely important, right? So AI assisted visual testing can help to identify the meaningful visual difference rather than treating every pixel changes equally. This is one example of how more advanced AI technique can be useful in the testing. Another example, if we can see, to analyze the screenshot from the field test cases or recognize the UI element or processing a large amount of text and logs. So now Rahul understand AI is a broad field. Inside AI, we have machine learning. Inside the machine learning, we have deep learning. But now something happens that completely changes the Rahul's understanding of AI. One day, Rahul opens an AI assistant and he enters this requirement. What is the requirement? After three incorrect login attempts, the customer's account should be logged. Then Rahul asks, generate test scenario for this requirement. Within a second, system responded with positive scenario, negative scenario, boundary value scenario, account lock scenario, password reset, security related. Rahul is surprised. He thinks, wait a minute here. Earlier, we were talking about the AI predicting something, which test might fail, which failure category something belongs to, which image contains a problem. But this system is doing something different. It is actually creating a new content. Exactly. And this takes us to a generative AI. So, what is generative AI? So, here comes the game changer generative AI. Generative AI basically refers to a system that designed to generate a new content based on the pattern learned from the data. That could be a text, that could be a code, it can be an image, audio, or video, and many other forms of output. So, for Rahul, generative AI can generate the test case, VDD scenario, automation code, API payload, SQL query, synthetic test data, bug description, and test reports, and documentation, and many more things. This is the one reason generative AI has created so much excitement in software engineering and software testing field. Earlier, many AI systems were mainly helping us with the prediction, classifying, and recognizing the pattern. But the generative AI can also create a new content based on the data, right? So that's how the generative AI is the game changer now, right? So Rahul, here's the another question now. Okay, if generative AI generates a content, then what is ChatGPT? This is good question, right? ChatGPT is an application which is built around all of these AI modules, including large language module designed to understand and designed to generate the language and also support many kind of tasks. Now, the important term for our next phase is LLM. LLM means to say large language model. LLM are a major technology behind modern text-based generative AI system. But don't worry, we are not going deeply into the LLMs today. That is coming in the next phase of this series. So for now, just remember when Rahul gives a requirement in normal English and receive a test cases along with the explanation or code, he is interacting with a generative AI system powered by language models or LLMs. So you guys are also giving us some requirement and getting a test cases or code or a script that is generative AI, which is powered by LLMs. Okay. So let's connect all of this together and imagine a large umbrella. At the top, we have artificial intelligence, which is AI. Inside that, we have machine learning, which allows system to learn from the pattern data. We see the different three types of learnings there. Inside that, we have deep learning. Deep learning use the multi-layer neural networks and which learns from the complex pattern. And then we have generative AI system that generates a new content. So AI is the big field. Machine learning teach system to learn from the data. Deep learning is a powerful machine. Generative AI focuses on generating a new content, right? So, so let's make this extremely easy to remember. Okay. Imagine Rahul's complete QA environment. Artificial intelligence. Rahul want to make some testing process smarter. Where the machine learning came, where when Rahul asked based on the previous execution, which test case have the highest risk of failure. Where deep learning comes, analyze this application screenshots and identify the meaningful visual problems. Where generative AI comes, when Rahul asks, here is my requirement and generate the test scenario or playwright automation skeleton. The system creates a new content. And that's all the difference between all these three: AI, machine learning, deep learning, and generative AI. So there is something very important for all the QAs. Now, there is one thing I want every QA engineer who is watching this series to remember. Just because something contains the word AI does not automatically mean it is an intelligent in every possible way. Different AI systems are designed for a different problems. A model that predict a test failure probability may not generate the test cases. A visual AI system may be excellent at detecting the UI differences, but may not know about the business rules. A generative AI module may write a beautiful test cases for you, but still misunderstand your requirement. So whenever you are using AI based testing tool, ask what problem is this AI actually designed to solve? What data does it use? What output does it produce? How reliable is that output? And how will I validate it? Those questions are extremely important for QA engineer, right? So let's quickly wrap this up. We learn in this today's video what is artificial intelligence, what is machine learning, what is deep learning, what is Gen AI, and all of this is a part of AI big umbrella. And modern deep learning has played a major role in enabling a generative AI system that we use today. Now, Rahul has discovered something very powerful. He can give an AI system a requirement. The system can generate the test case. He can give it an error. System can explain the error. He can ask for the code. System can generate it. Rahul, but now the Rahul has a new question. How is the AI actually doing this? How does it understand my English? How does it generate the Selenium or Playwright code? Does it actually know the answer? Or is something else happening behind the scene? And this is where our journey become even more interesting. Because in the next phase, we are going to enter in the world of generative AI and large language model. So we will understand what an LLM actually, how it processes the language, why tools like ChatGPT are able to generate these responses. So if you are following the complete AI for QA Engineer series, subscribe to Enhand Automation and make sure you don't miss the next episode. I'll see you there. Thank you for watching. Till the time, keep learning, keep automating. See you in the episode 3. Thank you.